coordinates and the relationship between rectangular and polar coordinates. Polar coordinates are not written as x, y. They're written as r comma theta, where r is the radius measured from the origin 0, 0, and theta is the angle measured from the polar axis. Meaning, if we're looking at the axes like this, the angle is measured from here and goes in the counterclockwise direction. The radius is measured from 0, 0 and measures outwards in the positive direction this way or in the negative direction this way. The first thing that we want to look at is the differences between rectangular and polar coordinates. Rectangular is x comma y, polar is r comma theta, and the relationship between those, all x coordinates can be written as r times the cosine of an angle, and all y coordinates can be written as r times the sine of an angle. The relationship between your x's and y's and your radius are similar to your Pythagorean theorem, x squared plus y squared equals r squared. And then we also have the relationship we've seen from previous chapters where the tangent of your angle is equal to y over x. So there's also a distance formula for polar coordinates where when you have two polar coordinates, r1 theta 1 and r2 theta 2, you can find the distance between them by using what's basically the law of cosine. So we'll see some of those later. The first thing we're going to do is look at how to convert from polar to rectangular in terms of equations. So for the first equation, when we have r equals 2 cosine theta, we want to change our r into an r squared, and we want to change our cosine into an r cosine so we can convert to x's and y's. So to do that, what we're going to do is we're going to actually multiply both sides here by an r. So when I multiply by an r on both sides, that gives me r squared equals 2r cosine theta. And remember, r squared is x squared plus y squared. And r cosine theta is x. So this gives me x squared plus y squared equals 2x. Once you have changed completely into x's and y's and there are no longer r's or thetas, then you are in rectangular form. If we look at our next one, we have a similar situation. We are going to multiply by r, but not yet because we have this double angle happening over here. So because we have this double angle with the cosine there, we are going to want to rewrite that using our double angle formula for cosine, which has us using r equals 3 times, and then the double angle formula for cosine that we'll use here, cosine squared minus sine squared theta. So when we distribute the 3, you see we have 3 cosine squared theta minus 3 sine squared theta. We need to multiply this entire side by r squared. So we have r squared cosine squared, which would be x squared, and r squared sine squared, which would be y squared. So if we do that over there, we have to do the same over here. So it gives us r cubed equals 3r squared cosine squared theta minus 3r squared sine squared theta. So this is x squared. So we have 3x squared minus, and then this is y squared, so 3y squared. And then this is equal to r cubed. So r cubed we want to think of in terms of how we could write it with r squared. So r cubed in terms of it being a power of r squared is r squared to some power. And so if we think of this as r cubed equals r to the 2x, then we can set our exponents equal to each other. So that gives us that exponent there would be equal to 3 over 2. So this side, the right side, r cubed is equal to r squared being raised to the 3 over 2 power. That's important because r squared, remember, is what we know is equal to x squared plus y squared, which means we can now write this as instead of r cubed, we would write that as x squared plus y squared to the 3 over 2 power equals 3x squared minus 3y squared. We now have gotten rid of all of our r's and thetas, so this is in rectangular form. When we look at number 3, we can see that this too is not just as simple as changing into an x, because this has the difference formula here. So our cosine difference formula here means that first we're going to rewrite this left-hand side so that we have r and then times our cosine difference formula. So that'd be cosine theta cosine pi over 6 plus sine theta sine pi over 6. And then that's equal to 2. So then we can evaluate the cosine of pi over 6 and the sine of pi over 6. So we have r times, that's cosine of theta, cosine of pi over 6, remember from the unit circle, is root 3 over 2, plus sine of theta times the sine of pi over 6, which if we remember from the unit circle is 1/2. So distributing our r, that's going to give us root 3 over 2 r cosine theta plus 1/2 r sine theta equals 2. So the r cosine is x, the r sine theta is y. So this is root 3 over 2x plus 1/2 y equals 2. And that is into rectangular form. We are going to now look at going from rectangular to polar. So the first one that we have here is actually just an ordered pair. So this is an x coordinate and a y coordinate, and we want to change this from xy to r theta. And we're being told that our radius needs to be positive and our angle needs to be between 0 and pi over 2. So we are going to use our formula for r. So our formula for r, x squared plus y squared is equal to r squared. So that would give us negative 1 squared plus 1 squared equals r squared, which would be 2 equals r squared. So your radius is either positive or negative 2, square root of 2. And because it's telling us that the radius must be positive, then we know that our radius must be the square root of 2. Then we need to figure out what our angle is. So our angle that we have would be tangent of theta is equal to y over x. So y is 1, x is negative 1. So we need to figure out what angles have a tangent of negative 1. And those angles between 0 and 0 and 2 pi would be either 3 pi over 4 or 7 pi over 4. So now we have to consider the location of this ordered pair, negative 1, 1. That is in quadrant 2. And because it's in quadrant 2, and because our radius is positive, it's going in the direction of that point, we are going to be using the 3 pi over 4, not 7 pi over 4, because 7 pi over 4 would be down here in this quadrant, and that's not where the point negative 1, 1 is located. So we have the ordered pair root 2, comma, 3 pi over 4. That is our r, comma, theta. So next we have for number 5, y equals x squared. And so to change this into polar, what we're going to do is change our y into an r sine theta and our x into an r cosine theta. And so what we want to try to do with these is get r by itself if it's possible. So in this case, that should be possible. So let's work through this a little bit. So we have r sine theta equals r squared cosine squared theta. And if I divide both sides by r, because the radius isn't going to be 0, then we get sine theta equals r cosine squared theta. And then if we divide both sides by the cosine squared of theta, we get sine of theta over, you can think of it as 2 cosines, which would leave us with, this is a tangent, and this is like a 1 over cosine. So this is like a tangent secant equal to your radius. Now, again, technically, we've already converted it to polar once we've gotten it to here, but to be able to graph in polar, which we're going to want to do later, you would want to get it into this r equals form to be able to graph it on your calculator. So for this next one, what we're going to need to do is, again, change our x's and y's into r's and thetas. So we have this x squared plus y squared, which is r squared. And then we have 4x, which would be like a 4r cosine theta. And then we have a 4y, which would be like a 4r sine theta. And that's equal to 0. So I can factor out my r, and that gives me r plus 4 cosine theta plus 4 sine theta equals 0. And so then I have, if I divide the r on both sides, I have this as my polar equation, and I can get r by itself by subtracting the r over and dividing by a -1, or subtracting the 4 cosine and the 4 sine over. So I have r equals -4 cosine theta minus 4 sine theta. The last one that we're going to look at here in terms of converting to polar is this one, where we're going to, again, first change our x's and y's into r's and thetas using the formulas we looked at. So if we look at what we have here, we have x squared, which is r squared cosine squared theta. And then we have this x squared plus y squared, which we know is just r squared. And then we have y squared, which is r squared sine squared theta. So if I divide both sides by one of these r squareds, then I'm left with r squared cosine squared equals sine squared. And to get my r by itself, I would divide both sides by cosine squared. So I have sine squared over cosine squared, which is like a tangent squared. So I have r squared equals tangent squared. And when I square root both sides, then I would get r is equal to plus or minus the tangent of theta. So that has solved this for r, and we would be able to graph that in polar form. The next thing that we want to do is find our given theta for these equations. And so the way that we're going to do that is by essentially just plugging in the values that were given for theta and then simplifying to figure out what our value for r is. So in number 8, we are told that theta is equal to pi over 6 and theta is equal to pi. So here we would plug in pi over 6 for theta first. And remember that the sine of pi over 6 is 1/2. So that gives us r is equal to 4 over 3 over 2, which is like 4 times 2/3, which would be 8/3. So when theta is pi over 6, r is 8/3. Then we do the same thing, but plug in theta is pi. So we have r is equal to 4 over 1 plus the sine of pi. And so that gives us 4 over 1 plus, and sine of pi, remember, is 0. So that gives us that r is equal to 4. So we're going to do the same thing here in number 9. So in number 9, we have r equals 2 cosine of 2 theta. So the first value we're given is 5 pi over 6. So if I plug that in here, I have 2 cosine of 2 theta, so 2 times 5 pi over 6, which if we simplify that, that gives me 5 pi over 3. And remember that the cosine of 5 pi over 3 is 1/2. And so that would give me 2 times 1/2, which gives me an r value of 1. And then we'll plug in our second theta value. So 2 cosine of 2 times 3 pi over 2. That gives me r equals 2 cosine of 3 pi. And remember that the cosine of 3 pi is -1. And so we get that r is equal to -2. And then our last example here, finding the distance between 3, 5 pi over 6, and 5 pi over 3. To do this, we're going to use the distance formula for polar coordinates. So that is d squared equals, we would have the first r value, so 3 squared, plus second r value squared, so 5 squared, minus 2 times 3 times 5 times the cosine of 5 pi over 3 minus 5 pi over 6. And so when we do 5 pi over 3 minus 5 pi over 6, we end up getting 5 pi over 6. And so simplifying this a bit more, that'd be 9 plus 25, which is 34. We have 2 times 3 times 5, which would give us 15 times 2, so 30. And so we have here 34 plus 30 times the cosine of 5 pi over 6. And remember that the cosine of 5 pi over 6 is root 3 over 2. So that gives us d squared is equal to 34 plus 30 times root 3 over 2, which would simplify to d squared equals 34 plus 15 root 3. And we want the distance, so we would now square root both sides. We'd get the distance is equal to the square root of 34 plus 15 root 3, or as a decimal approximation, your distance is to 2 decimal places about 7.74.